Hi. So this is the second episode in my series here. High School Math Fundamentals. I forgot to add it there, but that's what the HMF stands for. Okay, so this video is gonna be about solving triangles here. So I assume your teacher has already you know told you this neat way of remembering the ratios, the trigonometric ratios, your sine, cosine, and tangent. So sine, cos, tan. Right? So you probably heard the acronym SOHCAHTOA. Kind of sounds like suck a toe, but it's SOHCAHTOA. Right? So your S is for sine, right? Your C is for cosine, and your T is for tangent. And these ratios only apply to right triangles here. So let me draw a decent looking right triangle. And we will put a square angle here to show that it's a 90-degree angle. Okay, so say this is your angle theta. You usually use that Greek letter theta to represent an angle. So your sine of theta. Right, so let's label our sides here first, actually. So your O here is going to stand for opposite. Your H is going to stand for hypotenuse. Your A is going to stand for adjacent, and then these three are the same here. So our opposite side to this angle theta is this here. That's O. And our hypotenuse is here, H. And our adjacent is here because it's right next to it and it's not the hypotenuse. So a good way to remember it, if it's not touching it, it's the opposite. And if it's the longest side, it's the hypotenuse. And if it's touching it, but it isn't the longest side, it's the adjacent. So sine theta is opposite over adjacent because it's, opposite over hypotenuse because it's so. So that's just how sine is defined. So opposite O over H. Similarly, cosine is adjacent over hypotenuse. Tangent of theta is opposite over adjacent. Sometimes I forget this too. And, the SOHCAHTOA comes in handy there. Right. So let's start solving some triangles with this. Or I'll just use one example. So I'm freehanding this because it's smaller. So let's say we have this angle here, 58 degrees, right? And we have, let's say this side here is 12 meters. Okay? And we want to find this side here. That was not correct. Okay, yeah, that side there. Right? So how are we going to do that? Let's form an equation first. So we're going to make this our angle theta, that 58. So since we want to find this, we'll label it x. Let's say let x represent the leg of the triangle. The right triangle that is adjacent to theta. I should say theta, I should say 58 degrees. So a leg of a right triangle, by the way, is either of those sides. Those are both legs, and then this is the hypotenuse. It's both of the sides that aren't a hypotenuse. So what trigonometric ratio are we going to use here? It's not going to be sine, because we don't want to find the hypotenuse, and we don't have it in the first place. So since it has hypotenuse in it, we're not going to use it. Same with cosine. Has hypotenuse in it, not going to use it. Tangent, on the other hand, we're going to want to use here. So, and the reason being, tangent theta is equal to opposite over adjacent. And we have the opposite, and we want the adjacent. Both of those are in there, so we're going to be using tangent theta. Tangent theta equals opposite over adjacent. Tangent of what, though? Tangent of 58 degrees. And that is opposite, which we have to be 12 meters, when we put units at the end, over x. Right, because we said let x represent this leg, or the length of that leg. So let's solve for x now. We're going to cross multiply. Imagine this is over, imagine this is over 1, right? So tangent 58 degrees multiplied by x, and then 1 multiplied by 12. So let's do that here now. X times the tangent of 58 degrees equals 12. Okay, and so x is going to be 12 over the tangent of 58 degrees. Okay, so we can pretty much just punch this into our calculator now. Okay, so our x is going to come out to be 7.49. Around there. I'll just say 7.5 meters. So we know that now is the length of this leg. Okay, so it's a similar process for both cosine and sine. Just make sure your calculator is in degree mode if we're dealing with degrees here, not radians. I'll touch on radians probably when I do my video about solving trigonometric equations, but won't touch on that now. And what about the reverse? What if we wanted to find an angle between two legs of a right triangle? Say this is angle theta, and we have this hypotenuse to be 5 meters, and this leg to be 4 meters. Okay, how are we going to solve for angle theta there? Like, how do we know, how are we going to solve for that? So notice what we have here. We have the adjacent side because it's touching the angle. We don't have the opposite. And we have the hypotenuse here. So what trigonometric ratio uses both the adjacent and the hypotenuse? It's cosine, because cosine of theta is a over h. So write that down here. Cosine of theta is equal to a over h. Okay, so cosine of theta, which is what we want to find, is a over h. So a, our adjacent side, is 4. H, our hypotenuse, is 5. And so, to isolate for theta now, we're going to write theta here is equal to the cosine, the inverse cosine of 4 over 5. So pretty much what you're doing is taking the inverse cosine of the cosine of theta, which is equal to the cosine, inverse cosine of 4 over 5. You're taking the inverse cosine of both sides. And essentially what this will do to the left side here, it'll cancel the cosines, essentially, because the inverse cosine of a cosine of an angle is just the angle. Okay, so just punch that into your calculator now. It's that easy. Just make sure you're in degree mode again. So write that down here. Inverse cosine of 4 over 5. That is going to come to be theta equals, I'll round to 1 decimal place, 36.9 degrees. And so you can say, therefore, that is angle theta here. Okay. Perfect. What if it's not a right triangle, though? What then? So let's say we have a triangle like this. Okay, no right triangles here. Okay. We're going to use two laws here. The sine law and the cosine law. Okay. We're going to label our sides. We'll call this side A, side B, side C. This is angle A, angle B, angle C. Okay. It should be an uppercase C. So our sine law says that the sine of an angle, so let's say sine of angle A, over the side opposite to it is going to be equal to the same ratio, but for all the other angles and sides. So sine B over B equals sine C over C. Okay, and our cosine law says that, if I remember this correctly, a squared, so a side squared, doesn't matter, it could be B, C, a squared is equal to b squared plus c squared minus 2bc cos A. I am fairly confident on that. That is, yeah, that's right. And same goes for any of the other ones. So I'll just write them down quickly. B squared equals a squared plus c squared minus 2ac cos b. C squared equals b squared plus a squared, or I'll write that the other way actually. A squared plus b squared minus 2ab cos c. Okay, so yeah, no, the cosine law is a little bit of a hassle to remember. Just remember the square of one side is equal to the sum of squares of the other two sides minus 2 times the other two sides multiplied together times the cosine of the angle opposite the side you're trying to find. So this one correlates to that. Okay, so here's an example here of a triangle that is not a right triangle. And we're going to try and solve for the side B here. So you have two sides and a contained angle, which means you're going to be using the cosine law. That's just what it means. Okay, so we are going to write here then our b squared, that's what we're trying to find, is equal to, let's call this a, sorry, that's c and a, the 6 and 7, respectively. 7 squared plus 6 squared minus 2 times 7 times 6 times the cosine of 58. Okay, so b squared is equal to 7 squared, 49, plus 36 minus 2 times 7 times 6. 2 times 7 times 6, 84. Yeah, I think, yeah, 84. And then that's by the cosine of 58. Okay. So, our b is is equal to the square root of that. Because we're taking the square root of both sides, and that will cancel. So b, not b squared anymore, just b, is equal to the square root of 49 plus 36 minus 84 cosine of 58 degrees. Okay. Let me just calculate that really quickly. Okay, so our b is 6.36. That's rounded. 6.36 meters. That is what our side B is there. 6.36 meters. Okay. And sine law is a little bit easier than that. You won't have to remember that lengthy formula. So if we want to use sine law, say we have a triangle like this, right? And this here is 25 degrees. This side opposite to it here is, let's say, 5 meters long. And then we have another angle here where we have another side here that says, let's just say it's 8 meters. And we want to find this angle theta, right? We know now by this triangle, these are opposite and these are opposite. The angle's opposite to the side, I mean, in both cases. So we can use the sine law here. We have two sides, and we want to find the angle that, an angle that isn't contained between them. So we're going to use the sine law here. Okay, so sine of 25 degrees over 5 meters, let's write 5 for now, is equal to the sine of theta here over the length of the side opposite to it, so that's 8 meters. Right? We want to solve for theta here. So we are going to cross multiply this 8 by that, this 5 by that. So 8 times the sine of 25 degrees, and then it's equal to the 5 times the sine of theta. So that means sine of theta is equal to 8 times the sine of 25 degrees over 5. So I'm going to write on the other side now. Theta is equal to sine, the inverse sine, of all of this. Oh, whoops. Okay. Paste it. Right, okay. And that's it. Actually, you isolated for theta, now you just punch it into your calculator, make sure you're in degree mode. Okay, so I've just computed it. Theta is 42, rounding to two decimal places, 0.5 degrees. That's our angle theta here now. And that, for the most part, is how you solve a triangle, right? You will be using variations of this, and it's important to note that the sine law here and cosine law can be applied to right triangles as well, although it's not recommended because there's an easier way to do it, which is just using the SOHCAHTOA things that I mentioned earlier. But yeah. That's solving triangles. Thanks for listening, guys.